Okay, I'm following on from the previous video where I showed you a way to route the outputs of the panners, the Mach1 Spatial Panners, using essentially the hardware effects device, and this allows you to create the pseudo 8-channel output to route that to your speakers or the Mach1 monitor, and this all worked pretty well. Everything was synchronized, but if you can hear in the background, you can hear that the metronome isn't exactly in time with the hardware effects output. If I just stop that, if I just pump that out to the stereo, to the studio, you can see it's a round trip latency of 42 milliseconds, and that's why you can hear that that's out of sync, because the hardware effects device that we're using with the panner is it's a hardware proxy with an audio out and return, and what's that? That's basically going out the door and coming back in again, so that we can then send it on to the monitor. Basically, if you remember the jack graph, this has changed a little bit since the last video, but essentially we had the 8 inputs to the monitor coming from our 8 output buses, and then it goes onto my Apogee device, which is just what I'm listening on. We take a copy off to OBS, which is what you will see on this meter here. I will come on to what this is in a minute, but this is the next step in getting your kind of stems or your outputs into a multi-channel WAV file, so that we can transcode it into different formats. So hardware effects, we've got a 42.7 millisecond round trip latency, and that's loosely relating to I've forcibly set the sample buffer size to be quite big so that you can see the numbers, and we got, I mean, I think this is measured slightly differently, but that's basically where the latency is coming from. And I wasn't aware, but if I just disable this and enable this panner, so it's exactly the same sound source, exactly the same setup, exactly the same panner, and I play that, got the metronome on, you should hear this perfectly in sync. So we've got no latency there at all. If I just close the round trip off, taking it to studio, we can see 0.3 milliseconds. So that's essentially just internal latency of the Bitwig, I would have thought. So that's quite cool. It seems to use a bit more DSP. So I'm not sure how that's going to translate up. If you see, if I just play that, sorry, just take that out there. So we're 10% DSP for the grid, this grid method, which is what I'm going to show you. The device proxy method, which is, we're getting about 5% DSP, so it's not quite sure why that would be. It might just be how Bitwig's using the interface, maybe. I'm really not sure. I don't think it probably matters that much. So how am I doing it with the grid? Well, basically, it's exactly the same process. You've got your panner. We expose the output chains, but we use now the post effects chain, and we put one FX grid instance there, and in a very similar way we use the side chain, which is this output here. We split it because we need them in individual mono channels, and spread those to M1 to M8, and you can see that's all of our audio outputs available to us. And I've saved that as a preset. So I can't remember how you get to them now. I think is it there. I've saved them to devices preset and a grid preset, and I'll link to those so you can download them. So yeah, so that's quite cool, because we've got it didn't really matter that there was latency before, but it's always nice when you don't have to align anything if you need to, as long as this DSP doesn't get out of hand, but I don't see any reason why it should. So yeah, so with that said, if I return to the track we were messing around with in the previous video, activate that. There's only, I've tidied it up a little bit, and I've added a third track, just so we've got a little bit more to play with in this next transcoding stage. But I've added these, just a group of what I've just called them encoded loopbacks, because that's basically what's happened. The panner's encoded the outputs of each track, of the 3 tracks, and we need a way to record that. We could record it. We could just take the we could just take these outputs from the monitor. Sorry, not these outputs from the monitor. We could just take these outputs from Bitwig Studio and record those elsewhere in wherever that supports a multi-channel input. But as we've already got essentially this ability in Bitwig, we might as well use Bitwig to record as well. And so all I did was set up 8 input buses, and as you saw in the graph, the output, the 8 outputs of Bitwig are going through this new VST plugin called Unigain. And Unigain, all it does is it just gains all the channels at the same time. But it's a nice simple plugin, and we can just use that to route the 8 channels back into Bitwig to record them. You can't take the direct output bus back into an input bus. Bitwig doesn't seem to allow you to do that. So we have to trick Bitwig by running it through an external host, VST host, and then Bitwig doesn't know anything about the fact that this is exactly the same audio coming back in. And just to prove that works, I will just run this track. I'll just run this track through, and we'll record the loop back. So I've armed all those 8 tracks. This might glitch at the start, but we'll see how we go. Okay, so essentially we've just loop back recorded what is coming out of Bitwig, and we've now got those mono stems, if you like, in Bitwig. Now, what the reason we need that is the M1 transcoder is, I'll show you the command line version of it. There is a GUI version, but I'm going to use the command line version. This is what comes with the plugins, the panner and the monitor, because there's a whole software development kit behind all of this, and the transcoder is one part of that. And you can see all the elements, all the formats supported. And what I'm going to do is I'm going to transcode to Dolby Atmos 712. So this creates an ADM master file. It's only the bed, obviously, because you can't transcode objects and metadata to the Dolby Atmos format because that's proprietary to Dolby. But we can at least take our mix from Bitwig, and this is essentially the Mach1 Spatial format mix, and we can transcode that. So I'm going to show you how to do that. Now, if we could just export these audio tracks from here, but I could just say, right, I just want to export all of those. And that's one way to do it, but Bitwig will convert each of those mono recordings into dual mono stereo WAV files. So what you can do, if you go to the Bitwig projects directory, this is the project that I'm in, Mach1 routing. You will see that's, if you keep this directory clean, these files are basically those in mono format. And just to show you, if I show the track 1 in media info, we've got one channel, 48 kilohertz, which is what my interface is running at the moment, 48 kilohertz, and that saves us having to convert it basically. So what I'm going to do, I'm just going to cut these out. It doesn't really matter that you cut them out. Bitwig actually just keeps appending a new number on if you keep recording, over and over. And I need to get, I could go anywhere, but I will keep them all in this directory for now, just so that we can work in one place. Now we need to, the Mach1 Spatial format requires all of these to be in a multi-channel file. At the moment we're just in individual mono files. You can do this with various command line tools, FFmpeg and stuff, but if we just fire up Audacity, this is the easiest way to do it really, and it does actually use FFmpeg in the background, I think. So if we just take those files, copy those into Audacity. So there's our 8 Mach1 Spatial encoded files. If you just select all of them and go File, Export Selected Audio, and I just keep these same names because I've got the command already saved, and we'll save that as M1 Spatial WAV, and we'll replace it. And if you enable advanced mixing options in Audacity, you can map where you want each of these stem tracks basically to route. So luckily, because they're numbered in order, Audacity's ordered them 1 to 8, and so they just directly map to our individual 8-channel multi-channel file. Click OK on that, and export that. So you can see FFmpeg import, export, sorry. And if we go return back to here, we've got an M1 spatial file, and we should see, yeah, we've got an 8-channel format PCM. This doesn't really make any sense. There is no left, right, center, particularly. But anyway, we've got our M1 spatial file there now. If I return to the transcoder, and I'll just delete this file here because this is one that I've done before. And this is basically the command. So if you just copy and paste that into the command line, all this is saying is it's saying transcode this input file in this format, which is an Atmos ADM format, Dolby Atmos 712, and take all the channels that are in there. I think that's what that means. And so if I just hit return on there, so it's taken the M1 spatial WAV and it's created our Dolby Atmos ADM WAV. Now if I look at the media info on that file, you can see it's created a full Dolby Atmos master file of the bed 7.1.2. But now we've got that, we can bring this into Dolby Atmos and the Dolby Atmos renderer. So I'm just going to have to pause the video just while I set up DaVinci Resolve, because that's got a Dolby Atmos renderer in it. And then we can import that ADM file, and we'll see how it plays back. Okay, in Fairlight, there's DaVinci Resolve Studio Fairlight rather. There's the capability for mixing immersive audio, and that's generally set up, I think, in this immersive audio section of the audio I/O, and you'll see Dolby Atmos is an option. Basically, Fairlight includes the Dolby Atmos renderer, which is kind of like an internal, slightly stripped down version of the Dolby Atmos production suite, I guess. But it allows you to import and export master files and add binary metadata to objects and stuff like that. And it's perfectly adequate for pretty much most tasks. So what we can do in Fairlight, there's an import master file option, and there's our Atmos ADM that we transcoded from the Mach1 Spatial kind of master file equivalent. So if we import that will allow us to, I'm just going to keep this graph up because DaVinci Resolve keeps connecting itself and disconnecting itself. And this is imported essentially that 7.1.2 bed. Let me just pin this. It's imported the 7.1.2. It's automatically placed each position, which is what 7.1.2 is, the bed. Placed that in a multi-channel track. It's created the Dolby Atmos renderer master bus, and because this is a bed, it's also created a bed bus, submix bus, and that is output into main, which is the Dolby Atmos renderer bus, and then the track itself is output into this bus here. It's called it bed 1 to 10 because that's how it's identified the tracks that have come in. And so if we play that, it'll basically sound exactly like Mach1 Spatial, because it is basically. you'll see we're missing some channels in a 7.1.2, and that's purely because I haven't panned anything to there, so there was nothing to transcode. So with that said, this would be enough that we could simply, I mean, if we went to, I'm trying to remember where it is now, index, we've already got binaural metadata set for these. We could change that accordingly. There's 4 settings: off, near, mid, and far. So that controls kind of the binaural render mode that you would hear on not Apple Spatial, because Apple Spatial doesn't support it, even though it supports Atmos. But on Android, you would hear the binaural render modes, and yeah, we've got everything we needed now, and we could literally re-render that, export the master file, and then export. If we choose that same folder, so we'll call this Atmos ADM re-render. Save that. Oh, you need to define a range. Fairlight. Export master file. Export. We'll call this Atmos ADM re-render. Save that. And a little bit like the kind of Bitwig export, it'll just export that at double speed, and we've now got a re-rendered file. And again, if we look at that in media info, we'll have a very similar situation where we've got the tracks, channel formats, stream formats, but critically an ADM profile of Dolby Atmos Master, and that's pretty much how you would get completely to Dolby Atmos. In fact, you could probably not even bother with this step. You could just take the transcoded, but this does allow you to, as I said, adjust the binaural. You might even want to tweak the positions of things to suit Dolby Atmos or binaural better. I mean, what you can do, if I just get the meters out of the way, you can take this single multi-channel track. It's a bit convoluted how you unlink these, but I think you have to convert it to a link group. Just get rid of this media pool. Get rid of the index. Yeah, I think you convert it, so I guess that they're still linked. And then if you go to link group, yeah, now you can unlink the multi-channels, and that will put them out to separate tracks. So here we got now our 10 rather than a bed track, multi-channel bed track. We've now got single mono tracks, each with their own panner. I'm just going to switch that to come out the main, and they're routed. The buses are routed to the Dolby Atmos master bus. What probably hasn't happened is it won't know that we've obviously still got our 2 buses here, the bed and the main, just for the sake of speed. We'll just patch. So yeah, at the moment the bed's patched to the bed, although it's actually lost the connections. We'll just unpatch that, and then so the Dolby Atmos bed there's 10 bed kind of objects, and the remainder up to 128 are Dolby Atmos objects. What we could do, ignore the fact that this says bed, this is just how it's got imported, but we could patch those to objects instead of the bed. And now when we play that back, it'll sound exactly the same because nothing has effectively changed. We've just exploded the multi-channel out into mono channels, but quite cleverly, Atmos remembers the panning position. So we've got the panning position of all our objects. It's even transcoded across the height of whatever I did in this track in or track equivalent in Bitwig. And if we play that, it should just sound exactly the same as the bed. Okay, but obviously that would allow a little bit more flexibility because you've now got panning control of essentially the entire room now. And what that would allow you to do is theoretically you could import multiple beds and almost rebuild the kind of the Mach1 Spatial as a Dolby Atmos session almost. Whether you'd need to, that depends on what you're trying to achieve, but the option's certainly there. And so from there you would export this as kind of a re-render. So we'll export that. Export. In fact, I've already done one here, but we'll just overwrite that. So I've just called it Atmos ADM re-render. Replace that. Bit like Bitwig's export feature, it can export it without real time. So that's passed through the renderer. The renderer has taken any panning data and created another master file. Essentially, it'll be very similar to the transcoded one. We'll just look at the media info. Yeah, got an ADM master file, and it looks very similar because it is very similar. It's just that we've now got the Atmos objects now because I exploded the bed out and turned them into objects. And probably another little useful tool is Dolby Atmos conversion tool. If I just do a new session here, import master file. So this is the official conversion tool because there's kind of two master formats for Atmos. There's the ADM kind of WAV, and then there's the .atmos version as well, which is kind of like an exploded out version. And we'll just look at that because it's relatively interesting. So we'll choose the transcoded one. It's recognised that we're a 7.1.2 bed, which is correct. We'll convert that. We'll just create a folder for that. Just call it conversion, and save that. Okay, and that's pretty much done exactly what the Mach1 transcoder's done. And we'll see we've now still got all the same data, but we've now got a metadata file which had we would contain a lot more metadata. In fact, I'll convert the one that we re-rendered as well, and we'll look at that. It's also got the .atmos file, which is kind of like the tells the renderer at the kind of user's end, I guess, some additional details about what's the configuration of the file and all that sort of stuff, which you can look into if you want. .audio is obviously the actual physical audio. I'm not really sure what dBMD is. It's it looks like it's to do with the down mix. Yeah, so Dolby mix a down mix or something. Yeah, so obviously all of Atmos formats, excuse me, down mix to surround. So there's some certain rules of how you do that. So let's try. I'll just delete those out of there. Go back to the conversion tool. Excuse me. And we'll import our re-render, because that does have objects because we converted it. We'll just call that the same as before. Okay, and now I think if we look at this, we should see some of the metadata of our objects. So not, yeah. So we've got an objects beds 1 to 10. 10 to 19. It's added some data here that has gone through the conversion tool, and then in our main metadata of each object, you can now see we've got a huge amount more details now. So each object, so we've got ID 10 to 19, which is the same as 10 to 19 in the Atmos file. It's now telling us things like sample position, is the object active, how the panning is working, is it snapping to speakers, does it have any elevation to it, and quite importantly this binaural render mode. Even though it says undefined, that does actually mean mid. There's the metadata file uses near and far, but I think because mid is the default binaural render mode, it uses the word undefined for some reason. So yeah, it looks like at some point Dolby might include some sort of head track mode, which is quite interesting. I think that's an unused piece of metadata. But anyway, hopefully that shows you the entire process of getting to the Atmos master file and how you might want to tweak that. And likewise, you could really go to town and almost export each track as a bed object. But you kind of getting diminishing returns, I think, because you'd probably want to just mix in stereo in Bitwig, and then worry about the Atmos after. But if you wanted to try and do as much as you can within Bitwig, because let's face it, you want to make decisions in real time based on the immersive kind of experience and side to it. Whereas if you committed to stereo, that intermediary step is uncontrollable. You've just got to go with whatever you stemmed, and if you wanted to change anything, you'd have to go back to the Bitwig project and re-edit. So there's advantages and disadvantages to obviously everything. But anyway, that's showing you a basic conversion and re-render from the Mach1 Spatial transcode. Hopefully that shows the whole process. Next video, if I'm feeling brave, I will take an entire track through from Bitwig through to the Atmos master file, and then we'll upload it to something called Amazon Web Services Media Convert service, and that will allow us to get the DD plus Jock Atmos file. At the moment, we're only dealing in master files, which can't really be played back, and certainly can't be played back in any binaural sense. But if we get the DD plus Jock essentially transcoded or rendered rather from Amazon, we can I can show you a process of how you distribute that kind of spatial Atmos mix. And on Windows, that would play through. So I could probably show you here. That would play through Dolby Access. What Dolby Access does is kind of allows a. I need to enable it on the output. It enables something called Dolby Atmos for headphones. And so if it recognises that you're playing a DD plus jock track, you'll get it doesn't follow the binaural render mode exactly, but it does apply Dolby Atmos binaural to the mix. So we'll do that, I think, and the next step after that would be maybe publishing it to Amazon. So yeah, so that's pretty much what I wanted to cover today. I'll see you next time. Bye.